Hey you guys! Today we will assemble and test the Creality Ender 5. So you want to know more? Stay tuned! Hi guys! So let's start with the unboxing. But before we do, please don't forget to give the video a like, and if you are not a subscriber yet, go ahead and subscribe our channel. And if you wish to help the channel, please join our Patreon page or click on any of our affiliate links posted below in the video description. Okay, we are now ready to check what's inside the box. First, we have the assembly instructions. Next is the display. The extruder and stepper motor, then we have the Z-axis, this is the print bed equipped with a magnetic surface, and the top structure, which includes the X and Y axis. On the bottom foam, we have a spool of white PLA filament. A box with a few things inside that we'll check in a minute. Metal profiles, and finally the bottom structure.
Hey you guys, this is Rui. So, here you have the detailed manual. And the extruder stepper motor. And this is the display. This is a graphic display and it's exactly the same as the one used in the popular Ender 3. Inside the box, we have the power cord, a bag with tools, a bag with parts, the spool holder parts, and a spatula. In the tool bag, we have zip ties, round tip Allen keys and a small flat screwdriver and wrenches, and a needle to unclog the nozzle. Inside the cardboard, we have a wire cutter. Inside the bag of parts, we have a memory card and card reader, pneumatic fittings and locks, a couple of small bags with screws, and a plastic piece for the spool holder. And this is the Z-axis. The Z-axis runs on two linear rods, and the structure includes the Z end stop, the Z stepper motor, and the adjustable screw for the Z end stop trigger. Our Ender 5 version includes an anti-backlash lead screw nut. This will prevent the Z to go down if the stepper motor is turned off. If your Ender 5 does not have this anti-backlash nut, don't worry, there's a version that uses a different lead screw which will prevent the Z to go down, and therefore does not need the anti-backlash nut. And this is the base structure. On the metal plate, they printed the parts and the assembly instructions, the input voltage selector indication, and also the specs of the machine. A At the side, we can see the wires that need to be connected, and we can see that all have labels. At the front right, we have the USB connector and the memory card slot. And at the front left, we have the on and off switch. From the back, we can see the cutout for the power supply input voltage selector and the power cord connector. To access the electronics, we need to open the panel located on the bottom side by removing the 4 screws at the corners. In there, we can find the power supply and the main board. The power supply is a 24 volt and 14.6 amp model. Our board is a Creality version 1.1.4 equipped with a NetMega 1284P and Allegro drivers. The wires on the board side don't have ferrules on them and the tips are tinned with solder. As usual, this is something we like to fix right before our first power on, so we crimped ferrules on all the wires connected to the board. Okay, we have all the parts ready, so let's start the assembly. The first thing we recommend to do is to check the squareness of the frame. You can use a square and measure it all around. In our case, the frame was not squared, and we could easily see this on a flat table. The profiles are not assembled correctly. To fix this, we had to loosen the screws from the corner brackets and adjust the profiles. The same procedure applies to the top frame, but here we recommend to move the axis back and forth and see if they move freely. We also notice issues with the squareness of our top frame. One of the corner brackets has the end stop installed, so we need to remove the end stop first and then adjust the profiles. With the profiles adjusted, the squareness is now correct, and we can start with the actual assembly. For this step, we need the 4 metal profiles. Please note that the profiles on one end have an extra hole. You will also need M5x25 screws and spring washers. The spring washers must be inserted on the screws. Next, turn the bottom structure on its side and install the profiles with the extra hole away from the bottom structure. Make sure the profiles are aligned and tighten the screws. To make sure everything is squared, you can turn it upside down and check on a flat table. Next is the top structure. Make sure the hot end fan is facing forward. Secure it with 4 M5x25 screws at the top and 4 at the sides. Again, make sure the profiles are aligned and tighten the screws. Tighten the top screws first and then the side ones. Now we install the Z-axis. There are a couple of threaded holes on the back bottom profile and a couple of more on the back top profile, and we can use 4 M5x25 screws to secure the Z structure. This Z structure is installed with the Z stepper motor on the bottom side. Make sure the profiles are parallel with each other and tighten the screws. Do the same for the bottom profiles. Next is the bed platform. On the bottom side, we can see the connections for the bed. And from what we can see here, the wires are hanging here with no strain relief. This is something that should be addressed to prevent the wires to break while printing. There are a few options for strain reliefs that you can print, such as this one, for example. The manufacturer included a magnetic print surface on this standard version. To secure the bed platform, we use the M4x10 screws and spring washers. The holes on the bed platform must be aligned with the ones on the Z structure. The standard Ender 5 bed platform is only constrained on one side, and the bed is a bit wobbly, so when printing, make sure you have the printer sitting on a stable and wobble-free table. During the assembly, our cat Becky came to give us a hand. Well, sort of. Now we install the display. You need to rotate the T-nuts 90 degrees from each other to match the profile slots where they will be in. And when tightening the screws, make sure the T-nuts turn, because if they don't, the display will not be secured. The extruder and filament spool holder are installed at the back right side. The manufacturer normally tightens some screws so they don't get loose and get lost in the package. Before we can install the extruder, we need to loosen the screws a bit. The spool holder is easy to assemble. Make sure you rotate the top piece and lock it. The extruder is installed 80 millimeters from the top. And the spool holder 150 millimeters from the bottom. When done, check all the screws all around the printer. Make sure every screw is correctly tightened. And now for the connections. The display flat cable must be connected to the EXP3 connector on the display, which is the one on the printer side. The PTFE tube is inserted in the extruder fitting. The cables coming from the hot end don't have labels on them, but it's easy to figure out which one is which. The wires from the fans are the red and black and the blue and yellow. The nozzle thermistor is the one with white wires. The nozzle heater is the all-red one. Next, we have the wires coming from the bed. The bed thermistor is the one with the white wires. And the heater wires are the ones with the yellow XT60 connectors. Next are the stepper motors and end stops. Connect the X-axis stepper motor and the X end stop. Connect the extruder stepper motor the Y end stop the Y stepper motor and the Z end stop. To connect the Z stepper motor, raise the Z manual a bit by rotating the coupling. Try to arrange all the cables and make sure they don't get pulled when the axes are moving. Last but not least, place the lock on the extruder fitting. Before turning on the printer, we recommend to check a few things first. The two Y-axis belts tension needs to be checked. If you need to adjust the tension, loosen the 3 screws at the side and tighten them back while pulling the idler. For the X-axis belt, the procedure is the same, but you only need to loosen a couple of screws. Next is the wheel's grip. The inner wheels of the Y-axis carriages have eccentric nuts to adjust the wheel's grip. If the wheels turn freely, get a wrench and turn the eccentric nuts only until they stop turning freely. We have a video that explains how to adjust the eccentric nuts in detail, so go ahead and check that video as well. Wait a few minutes and check the axis movement. If you feel like there are bumps while moving, it means you turn the eccentric nuts too much and the grip is too strong. For the x-axis, there is only one adjustable wheel with eccentric nut, and it's located at the bottom near the nozzle. Do the same procedure for the x-axis. Now we connect the power cord and the assembly is now complete. This Ender 5 has model firmware installed, and menus are very simple to use. In the Prepare menu, we can home the axis and move the axis by a certain amount. The bed auto leveling option does not mean it has an auto level sensor. Instead, it will just move the nozzle to the four corners to help the leveling procedure. And we can disable just the X and Y stepper motors or all of them at once. In the control, we can set the temperature for the nozzle and the bed and turn on the layer cooling fan. We can adjust several settings such as accelerations, speeds, jerk, and steps per millimeter. And we can save, load, and restore the factory settings. Before our first print, we need to level the bed, so let's start by heating up the bed up to 60 degrees C. Rotate the Z and stop trigger screw so that it stays at the lowest position. Move the Z up by hand until the end stop is triggered. If the nozzle touches the bed before the switch is triggered, rotate the knobs to compress the springs a bit more. Next, go to the bed auto leveling option and select Next Step. The printer will home all the axes and then will move the nozzle to the first corner. Get a 0.1 mm thick piece of paper and adjust the knobs until you feel the nozzle touch the paper. Select the next step and repeat the process on the other corners. If you take a bit longer to adjust, the screen goes back to the main screen. It will not start over, but it's a bit annoying to go through all the menus again. We also recommend you to run this leveling sequence more than once, and as many times as needed until you get all four corners correctly leveled. The last step will move the nozzle to the center. This will allow us to check if the bed is warped or not. If you have a warped bed, check our leveling video where we talk about this procedure in more detail and a few solutions for warped beds. And now we can load some filament and run some prints. Be careful when inserting the memory card. If you miss the card slot, it will fall inside the enclosure. For our first test, we printed one of the G-codes available in the memory card and with the PLA filament that came with the printer. Since the X-axis homes to the right side, all the prints will be made with the models facing the back side. If you want to have your prints facing forward, you need to rotate them in the slicer. Next, we printed this small pig figure with our own S3D profile. Then, as usual, we printed the Benchy. We only use PLA for our tests, and in Vase mode, we printed this jet airplane. And here are the results. The dog printed with the already sliced G-code wasn't bad, but not perfect either. The figure printed with our own profile turned out a lot better. The Benchy shows the traditional diagonal lines from the Allegro drivers. These can be eliminated by upgrading the board. Together with the salmon skin, we also notice ghosting on some prints, but more noticeable on the Benchy. And the jet airplane printed in Vase mode. The tip of the plane shows fairly good layer cooling capability. In the machine specs, it's written that the print volume is 220 by 220 by 300, but the bed is 235 by 235, and the firmware allows us to move 230 mm in X, 225 mm in Y, and 305 in Z. The stock firmware does not have the thermal protection enabled, so we recommend you to install a version with the thermal protection as soon as possible. The bootloader is also missing, so you need to install that before flashing a new firmware version. You can check our Ender 3 firmware installation video since the procedure is exactly the same. Regarding cable management, it would be great if the cables were a little bit longer. With longer cables, they would look a little nicer than this. This Ender 5 has basically the same components as the Ender 3, but built in a cube form factor. The print surface moving up and down is an advantage when compared with the Ender 3. In spite of its cube shape, the Ender 5 is not a Core XY machine, since it uses different stepper motors to move the X and Y axis. So, what do you guys think? Feel free to leave your comments down below. And that's it, you guys. Hope you liked the video, and if yes, please give it a like. Also, don't forget to subscribe to the channel if you are not yet a subscriber. We will see you guys next time. Bye!